everybody, this is Mrs. Wise. Welcome back from spring break. We're going to begin with graphing radical functions now. So we're going to begin with what's graphing the following function, the square root of x. So the square root of x, if you make a table of values, we're going to start with 0. Square root of 0 is 0. Okay, and so that's going to get rid of this just as 0, 0. And then we're going to, we can't get the square root of anything negative, so that's going to cut off this whole part of this graph over here. So we're going to move over to the square root of 1, which is 1. 1. And then the next square root we can take is 4. So the square root of 4 is 2. So go over here to 4, 2. And the next one is 9. And the square root of 9 is 3. So it's good to pick values. You can take the perfect square root of them. It's nice. So we end up with this sort of a half parabola. And we'll get into that a little bit later because this reflection down here is going to have a half, like a sideways parabola. But when we have just the positive part of the square root, it's just the upper part. Okay. And sometimes we get into this plus or minus square root, and we'll learn more about that later. So it just starts at the origin here, and it's like a half a parabola, so it kind of arches up here just like this. Know this parent function. Okay, so square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. You're going to want to know those starting points as we start to learn how to transition those and translate those. Okay. So to graph this following function, what's the domain and range of this function? Let's go back actually. What is the domain and range here? My domain is my all of my x's greater than or equal to 0, right? My range is everything also greater than or equal to 0. So y is greater than or equal to 0 there, okay? And the function is always increasing, right, from 0 on, okay? Okay, so now let's look at this one here. So when you're choosing tables for this one, table values, again, try to make it so you can have a perfect square root. So if I plug in 0 there, it's still going to be 0 again. If I plug in 3, 3 times 3 is 9. And so you notice you get a perfect square root. So that's why we want to pick the value of 3 for x. So 3 times 3 is 9. The square root of 9 is 3. Okay? If I plug 12 in there, 3 times 12 is 36. And the square root of 36 is 6. Okay, and continue to go on. So here's our graph here at 0, 0. I could have plugged in. I guess plug in 1 there. So here's our original graph here. It's our parent function. Okay. So if I take my current function now, 0, 0, and I go to 3, and 1, 2, 3 here. Oops. 1, 2, 3 here. And I go over here to 12. So this is 4, 8, 9, 10. And I'm going to go to 12. I'm going to go up here to 6. I think that's 6. Okay. And then here's my graph here. So notice that 3 just kind of stretches my graph, right? It makes it taller on the x-axis, on the y-axis, excuse me. So it stretches it up this way with a stretch. We take those parent function values and we stretch them, okay? Okay, so now how do we graph a cubic function? So again, I'm going to make a table of values here, x and y. And I want to pick perfect cubes. So I'm going to kind of start, first of all, 0. I put that in the middle because that's what you'll see in a minute why I put that. The cube root of 0 is 0. If I plug in 1, the cube root of 1 is 1. So again, I want to pick perfect cube numbers. So our next perfect cube number is 8. Right? If I plug in 8, the cube root of 8 is 2. On the other side, I can take a cube root of negative 1. So the cube root of negative 1 is negative 1. And the cube root of negative 8 is a negative 2. So now if I plot these, I have 0, 0, 1, 1, 8, 8, 2. Okay? And over here, I have negative 1, and negative 8, negative 2. And this graph will look a little bit familiar. If you guys remember, our cube root graph kind of goes like this. Our cubic graph. Our cube root graph kind of goes sideways like this. Instead of vertical like this, our cubic graph went, okay, this one kind of goes sideways, okay? And we'll get into that again a little bit later, okay? And that's what a cubic graph looks like. So what does this one look like if we have an x plus 2 on it? So again, what I like to do if you want to pick table of values is I want to pick values that I know will work. And so negative 2 is going to be the first one I pick. And that's because negative 2 plus 2 is 0. And so now you know why we kind of shift opposite to get our 0 point. Okay? Then I will also pick probably negative 3 on this end because negative 3 plus 2 is a negative 1. And I know I can take the cube root of negative 1, which is negative 1. Okay? I'll also pick like negative 10 because I know negative 10 plus 2 is a negative 8. And the cube root of negative 8 is negative 2. Okay? On the other side of this little fulcrum, this is kind of like my little fulcrum point, my little bendy point, I'm going to go the other way. So since I only went 1 that way, I'm probably going to go 1 this way. So if I pick negative 1 here, negative 1 plus 2 is positive 1. And the cube root of positive 1 is 1. And the same thing, I want to try to get 8 in here. So I'm going to pick my value of 6. So 6 plus 2 is 8. And the cube root of 8 is 2. So that's kind of a little how we want to pick our values, you know, not just random values. It's a little bit easier that way. Okay? So we have 10, negative 2. Or negative 10, negative 2, excuse me. We have negative 3, negative 1. We have 2, negative 2, 0. We have negative 1, 1. And we have 6, 2. Right? So you can kind of see that the same thing applies for all these graphs. It just basically took my graph, my parent graph, and shifted it to the left. Because there's my 0, 0 point. There's nobody over here. We shifted it to the left, negative 2. Okay? Just like our regular translations with all of our other graphs. Okay? So you might want to try this in and see how you do. Okay? So this is a square root function. Okay, so it's just going to have a little root. Okay, so here's my graph, my parent function here. Really quickly, that's what it's going to look like right here. That's my parent function, to give you an idea. Okay. You could do table of values, or you can just use a shift in your functions. I'm going to go ahead and use a table of values. So I'm going to go ahead and put 5, because then 5 is going to bring this back to 0. So keep square with 0. And then I want to know what's going to get me to 1, right? So 6 minus 5 is 1. And so actually, I don't need to do this on the square roots. I don't need to do this part because there's nothing on this side of the 0 point that's going to give the value for. So if I just start with 5 here, 0. Then if I start with 6, 6 minus 5 is 1, and the square root of 1 is 1. If I want to try to get it to 4, right? So if I want to try to get it to 4, what is that going to be? 9. So 9 minus 5 is 4, square root of 4 is 2. All right, so let's go that far. Let's go to 5, 0, 6, 1, and 9, 2. So this just kind of gets our graph started here. So you can see how I just took my parent function and shifted it to the right 5. Just like all of our other shifts. So you want to try this one? This one is a cubic function, so it is going to have a bendy point. So I'm going to put the negative 1 down here. That's our 0 point there. On the other side, if I go, what's going to give me 1 is going to give me 0. So 0 plus 1 is 1, and the cube root is 1. Okay. What will give me 8 is 7. So 7 plus 1 is 8, and the cube root of 8 is 2. Let's go the other way. So if I plug in negative 2 here, that will give me negative 1. And the cube root of negative 1 is negative 1. If I plug in negative 7, negative 8. We want to get 8 here, right? Or excuse me, negative 8. So we're going to have to plug in negative 9 to get negative 8. And that will go to simply negative 2. So we plug all this in. I don't go out as far as negative 9, so let's go to negative 2, negative 1. Negative 1 is 0. 0, 1. 4, 5, 6, 7. We'll go ahead and 7, 2 again. And so we know that we're going to be doing something like this for our graph. Okay? So now that we know what that looks like, we can realize that, hey, all of those stretches and shifts and so forth are just the same in our radical function. So H determines our left and right, K determines our up and down, and this determines our vertical stretch. Okay? So let's apply that to a couple of these guys now. So we have this graph of this 2 times the square root of x plus 3 plus 5. And what transformations map the graph of f of x to the square root of x? To the graph of g. And then what's the domain range? So right here we can notice that we're going to shift to the right, to the left 3. So it's kind of counterintuitive. So if they rewrite this as x minus my shift. So we just know it's going to shift to the left 3. It's going to shift up 5. and then we have this stretch of 2. Okay, so I'm going to go to my next page here, and this is what we have. Here's my parent functions at this F right here. My stretch is my orange, so we took each of these y values here. So right here is 4, 2, right? So right here at 4, 2, we stretch it by 2. So this is going to be a value of 4. Well, 4 times 2 is going to be 8. Okay? If we take this value out here, let's see where we at here. This is about 4, I think. So then 4 times 2 is going to be 8. Right? Right here. Okay? Oh gosh, what's happening now? Okay. Let's go back here. I'm sorry. This is 2, and then value of 2 times 2 is 4 right here. And out here, my value is 4, and 4 times 2 is going to be 8. So you kind of see how those stretch. Okay? Then we take that function after we've stretched it, and we're going to shift it. We're going to shift it up 5 and over 2. 3, 2. Okay? Up 5 and over 3. And then we get a graph. Okay? So now let's go ahead and try some of these guys. So if we have our parent function, sometimes it helps to start with that parent function. 0, 0, 1, 1, 4, 2, and so forth. Okay? What is our stretch, first of all? Okay? Is 1/2. So I'm going to stretch all these to 1/2. So I'm going to take this y value of 2, and we're going to multiply it by 1/2. I don't know why I keep doing it. Multiply it by 1/2 and put it right here. Okay? I'm going to take this y value of 2 and multiply it by 1/2, which becomes a 1. There's 0, 0, so the same. So here is my 1/2 of that graph right there. Now we're going to shift it to the right 1 and down 3. Okay? So you're going to take this point with 0, 0 and go to the right 1 and down 1, 2, 3. You're going to take this 1/2 point right here and the right 1 down 1, 2, 3. And we'll take this point right here, go to the right 1, down 1, 2, 3. And this will be our translated graph. Okay? So you might want to take note of those translations and how those work. Okay? So now we're going to look at how do we rewrite these functions so we can actually tell what the transformations are. This 9 in here kind of is funky. So the first thing we're going to do is just kind of separate it. Square root of 9 and the square root of x. The square root of 9 is 3 square root of x. Now we can tell what our graph is and what the transformations are. We have a stretch of 3. Right? So we take our original parent function here, 1, 1. So 1, 1, there we go, 4, 2. And we graph that guy. Then we can take this function and stretch it all by 3. So this y value of 1 multiplied by 3 gives me 3. It's really irritating sometimes. Gives me 3 there. This y value right here, 2 multiplied by 3 is going to give me 6. And I can get kind of an idea of that at that point there. And it's going to make it just a really steeper graph and shoot it up higher. Okay? One more is this guy. We want to make it look like this here, right? So we want to take that square root of, kind of factor out a 4 in here. So it's 4 times x plus 4 plus 7. So now we have 2 factors in here. We can separate the square root of 4 times the square root of x plus 4 plus 7. Okay? And now I can take the square root of 4, which is 2, and the square root of x plus 4 times 7. And that's my h of x. So now we can actually identify, what my left and right are. We're going to shift left 4, up 7, and we have a stretch of 2. Okay, so let's go ahead and we get our parent function in here. Okay, we get this parent function going on here. And let's go ahead and stretch each of these guys by 2. So take that 1 and multiply it by 2, becomes 2. We take that 2 here and multiply it by 2, and it becomes 4. We take the 3 up here and multiply it by 2, it becomes 6. So this is our new stretched graph right here. Now we can shift it. Okay? So we're going to shift it left 4 and up 7. Okay? So we take this new 0, 0, 0, left 4, up 7. Okay. This 1, 1 was right here. This is this guy right here, so we're going to go left 1. No, left 4. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. 4. Okay. We take this guy here and go left. And go left 4. 1, 2, 3, 4, and then up 7. 1, 2, 3, 4, 5, 6, 7. And we've got to be good enough for now, so let's put this guy in. There's our new graph. Okay? And so all of the shifts and all the transformations are the same, just like all our other graphs. We just have them in numerical form. Okay, so what transformations of the parent graph of f of x equals square root of x produce the following graphs here? So we want to try to get this, in a form where this is the coefficient here. We want to get this here. We're going to factor out a 4 inside here to leave us with x minus 3 minus 2. Then we can separate these guys. Square root of 4 times the square root of x minus 3 minus 2. 2 times the square root of 4 is 2, so it's 2 times 2. And this time the square root of 3, x minus 3. Leaving us with 4 times x minus 3, square root of x minus 3, I should say. Okay? And so now we know that we have a vertical stretch of 4. Stretch. We have a horizontal shift of 3, and we have a vertical shift, -2. Okay? Until then, you can't really tell what the transformations are. All right? So that is what you have today. Be sure to attach all your work and answers to your worksheet and show all your work in your worksheet, and then I will see you soon. Talk to you later. Bye-bye.